So today we're very happy having this chance to introduce Professor Wang from Nanjing Tech University. So very good to see you again, Dr. Wang. So could you please briefly introduce your group and research in general?
Okay. Hi everyone, I'm Lin Wang from Nanjing Tech University. It's a great honor to meet our VP and also everybody in front of the camera. My research interests are mainly about two-dimensional materials and devices. And our group in total now has, I think, more than 14 members, including the students and the young scholars. Our research direction can include the synthesis of two-dimensional materials and also the physics optical properties of two-dimensional materials and also some two-dimensional semiconductor devices, including memory devices, phase effect transistors, and also photodetectors, something like that.
40 members, that's a very big group.
Yeah.
Yeah. Okay, thank you for your introduction. As mentioned in your presentation, the 2D material provide a new platform in the post-Moore era. So could you give us more information about this post-Moore era?
Yeah, actually, there is a great scientist called Moore Gordon. There is a very popular people called Gordon Moore. He has said that in around 18 to 14 months, the number of Earth's integrated chip will be increased by twice. Actually, when we reaching the physical limit, now the Moore law has been broken. So now we have come into the post-era Moore. We have come into the post-Moore era. Actually, there are two main routes for post-era development. The first one is called Moore, that people want to make the devices smaller and smaller, and that is in respect of size integration. And the other route is called more than more, that the people want to make the function of a single device more functional. I think two-dimensional materials can combine the advantages of size integration and also function integration, which hold great potential for future semiconducting materials and devices. That is also the reason why our group put so many effort on two-dimensional materials and devices.
Thank you for your explanation. So also we have noted that your group is focusing on the circular polarization luminescence. So could you share some information with us, like how could we build this CPL microscope system and what information could we get from it?
Okay, actually the method is very simple. You can use three different methods to do the CPL measurements. The first one is we call the CPL excitation, that you put one-fourth wavelet in the excitation laser, and then you can excite the light with different circular polarized light to see what kind of different behavior of the materials can have at a different polarized light. The second one we call the CPL detection. That means you put one wavelet in the place of the detection part, that you can try to see what kind of different behaviors can the material emit. And the third one, that you do both. You can put one fourth wavelet in the excitation part and also one wavelet in the detection part. Then you can do to see the behavior of some very emerging two-dimensional semiconductors, including MOS2. Actually, the CPL measurements, I think, is very important for the spin polarized. Actually, I think CPL measurements is very important for spintronics and valleytronics field. That to see the carrier with the actual freedom of spin, what can it holds for the future photonics devices.
That sounds like a very strong system with multi-functions, like suitable for different tasks. Yeah. So, Dr. Wang, do you have some stories with Zolex to share with us?
Yeah, I think there are many, but the most important part I think is that I chose the first equipment in our lab is Zolex.
Oh,
Yeah, actually we think this is a very important system for us because we do all the PL measurements, Raman measurements, photo current measurements, something like that. All the results are coming from Zolex system. So in the past 6 years, Zolex system help us to obtain a lot of plentiful results and helped me to publish a lot of papers and also made me understand the two-dimensional materials and their devices better and better. So very thanks for Zolex, and I also hope I can grow up with Zolex more.
it's really our pleasure and honor to be a part of your research, and we could assist like your study and help your group to get more publications.
Thank you.
Yep. So, do you, in general, have any ideas or expectations to domestic instruments in general?
I think yes. Like other Chinese researchers, actually, I think every Chinese researcher want to use our equipments. But the thing is, the national equipments are not that mature or that not good enough. But I truly believe that national instruments will grow up with our Chinese researchers because we can also see our Chinese researchers were not that good in the past, but now we are whether the papers or the patents or other things will let other people see us. I think national instruments will also have this kind of trend that it will let others see of the world more and more.
Yeah. Thank you. Thank you very much, Dr. Wang, so that we have this chance to interview you. And that's pretty much it. Thank you. Thank you very much.